Hi guys, this is Web3 Boy and welcome back to the channel. And today we are going to be discussing about telephone problem of Open Zeppelin. And this problem actually wants you to claim the ownership of the contract below to complete this level. So this actually wants you to complete this level by taking the ownership of the contract, right? So before moving on any further, I will just initiate the transaction to get a new instance of the existing contract, and I'll just confirm it and then I'll move on further. So what it says is you have to see the question mark page above and section beyond the console, right? This beyond the console section actually says that you have to move to remix ID and do something from there, right? So we have now new instance of this, and I'll just do a few things to let you guys know. I'll await contract. So I'll do this so that you guys know what's the address of the contract. And one more thing, await contract dot address. So when you do this, you'll get this contract address, right? So these both are same. Okay, so this is the contract address, right? Again, I'll do await player's address. I'll show you what's the player's address. Like this is my address. So, and also await contract.owner. So I'll show you who is the owner of the contract right now. So this is the owner of the contract, right? And this is actually the contract's address, basically the instance address, and this is the player's address, right? So what this particular problem wants us to do is this wants us to change the owner's contract to the player's contract, right? This is the player and this player should be the owner of the contract, so this address should be replaced by this, right? And when we are able to do this, we have successfully completed the challenge. So let's just copy this, and I'll do the general walkthrough of the code first, general review of the code first, and then secondly I'll discuss about difference between transaction.origin and message.sender, right? Because this particular problem actually wants you to know more about transaction.origin, right? So I'll just do the general review of the code. Let's just do the difference between this. Okay, so here I want you guys to know what message.sender is and what transaction.origin is, right? So when you initiate a transaction, the initial block of the blockchain, the initial block of the blockchain is actually the transaction.origin, and this particular transaction.origin is always a user, right? Because when you deploy a contract, over a blockchain, it is deployed by a user. So transaction.origin is always a user, but message.sender cannot. I mean, it can be a user or it can be a contract's address. How? Let's just see this particular diagram. I found this diagram over the internet, and let's just see it. Excuse me. So this is particularly the scenario 1. Here is the scenario 2. Here is the scenario 3, and scenario 3 is actually our telephone scenario, right? So when the scenario A says when a user wallet actually deploys a contract, so the user wallet is the transaction.origin as well as message.sender, right? So again we have second scenario wherein a user wallet deploys a contract A, and that contract A basically interacts with contract A. So for this contract A, message.sender and transaction.origin both will be user wallet, right? But in scenario 3, if user.wallet actually deploys a contract A, and contract A deploys a contract B. So for contract B, message.sender will be contract A, because this is the block that is mined just before this particular block, right? So for contract B, contract A is going to be the message.sender, because message.sender is actually the latest block, right? Latest block or latest address that has been interacting with this particular contract, right? But transaction.origin is the original contract address, original user wallet address that has deployed the contract, right? Basically the starting of the chain, right? So for contract B, transaction.origin is going to be the first block and message.sender is going to be the latest block, right? So this is the difference, and this is where the vulnerability lie. And let's go to the general review of the code, and I've copied it already. I have copied the code. So here's the code. Here is Pragma Solidity version. This is contract telephone. This is our owner, that is of address type, right? We have a constructor that sets the message.sender is equal to owner, and then we have this function that is change owner that takes in a parameter as underscore owner, and it says if transaction.origin is not equal to message.sender, owner should be equal to underscore owner, that is the parameter we are passing here, right? Let's see how we can basically exploit this particular code. So I'll not be writing it again because I have written it once again. Written it before. And for you guys, I want to tell that I was not able to crack this. So I took a help of YouTube videos and some references, and that's how I was able to write this code. So let's just go and check it out. So here is the telephone contract, right? So this telephone contract is actually the original contract, this telephone, right? So, and I'm importing the telephone.sol contract, right? And again I'm writing this contract as attack, and here we have a telephone contract, and this is of type telephone, that is this particular contract, right? Then we have a constructor. This constructor takes in a parameter, and that parameter is going to be the address of the contract that we are going to provide, right? And that is going to be basically this, right? So this is the telephone contract address, basically the contract address of this telephone, right? And when we'll pass this telephone contract address, this address combined with the ABI of this telephone will give a new instance of the address, and that instance of this particular contract is going to be stored in this variable, that is telephone contract, right? And lastly will be this is the function attack, and lastly what we will be doing is we'll be calling this function, and inside this function we'll be calling this telephone contract variable. This variable has the instance of this particular contract, that is this telephone contract. So inside this we'll be calling change owner. This change owner is the function that is specified over here, and we'll be passing in message.sender as the parameter, right? Because here it is asking for a parameter, and message.sender is going to be the parameter, right? So let's see, let's just I'm deploying this telephone contract address first. So when I am deploying this, I'm actually deploying the original contract, right? And then in the attack contract I'll be passing in as a parameter. To get that instance, I'll be passing in here you can see constructor, and that constructor actually wants telephone contract address. So for telephone contract address I have already took out the address, and this is the address actually. So I'll just copy it here. I'll just copy it and I'll pass in as the parameter over here in the attack contract, right? And I'll deploy it. So what happened when I deploy this contract, what happens is this will actually make an instance of this telephone contract, right? So you will have the contract instance, and taking that instance you can deploy the attack contract, right? And then you can call in this attack function, and when you'll be calling this attack function, it will definitely change the owner of the contract, right? So I'll just call the attack, and before calling the attack I'll show you that who is the owner still. So the owner of the address is this, but after calling the attack it should be changed by our address, that is the player's address, and hence we'll be able to complete the challenge, right? So the contract this is confirmed, and let's just see who is the owner now. Okay, so the owner is changed to the player's address. So basically we have completed this challenge, and I'll just submit this so that you guys can confirm whether we have completed or not. So let's just confirm it. So it is completed, and we'll when it will be completed, we'll see lots of congratulations over here, and let's just wait for it so that I can show you that we have completed this challenge. And okay, here it is. So it says, well done, you have completed this level, right? So this is it, guys. We have completed this challenge. Here you can see, while you can just see what happened to this, what can be the solution to this, right? So you can read it after completing the challenge. And one more thing I want you guys to know it, how to avoid this vulnerability, right? I got this from our internet, and you guys can check it out also. So it says never use transaction.origin as an authorization check on who's calling your contract, because when you check transaction.origin, it'll be checking for the first block of the blockchain, but it will not check the latest block of the blockchain, right? So let's say I'm sending the transaction and I am invoking a transaction on the blockchain. So if you are checking that transaction with transaction.origin, it will not show the correct message.sender, right? Because I am going to be the message.sender, because I am invoking the contract transaction, but transaction.origin is the first block, so I am not going to be the transaction.origin. And use message.sender if you need to authorize the immediate sender, right? So if you want something to happen to your smart contract with the latest block that has been mined, the latest the latest sender to the contract, so you should use a message.sender. So this is the key takeaway from this particular contract, guys. And this has been done. I'll do the next challenge, that is token, in the next video. And if you guys like my video, please subscribe to the channel. I'll be doing the complete challenges over here in the next few days, and please subscribe to my channel, and I'll see you in the next video. Till then, bye bye, see ya.